Alright, so today we are starting our Ink smart contract development, and yes, we're going to explore a lot in the Ink smart contracts world. We've completed our Rust bootcamp, and we are going for our Ink bootcamp that is happening this week. So yeah, it's exciting, and we are going to be going through a lot of things, just adding on to building with Rust. So let's get started. Okay, so I'm using you can go to the ink documentation, ink documentation. So I think it is used .ink, and then yes, you'll be at this place that welcome. So this is mainly talking about Rust, page availability, WASM, Polkadot, and where Ink smart contracts are deployed. Okay, I'll quickly go through this so that we can go to the development. At least we deploy our first smart contract and things like that. So why Rust? For smart contracts, Ink chooses Rust, not invent the wheel, but we know that Rust is an ideal smart contract programming language. Yeah, type safe, memory safe, and free of undefined behavior. And Rust actually has a very it's like an industry standard, as an increasing community growth too. So we have a Rust ecosystem. Yes, can gain a lot of support tooling because Ink follows the Rust standards like RootMS. It's no overhead, safe and efficient, productive. Cargo crates.io, you can use many of the crates that are on crates.io while building your smart contracts and so on. So first class WASM, small size, and so on. Then why WebAssembly? So WebAssembly blobs because there's of high performance, small size, general virtual machine bytecode, efficient and just-in-time executions, minimalistic. So when you look at these are some of the reasons that you should use, that will give you capacity to use Ink. But I encourage everyone to go through these and read smart contracts in Polkadot. What I typically get when somebody learns about Substrate, Polkadot, Oksama is when to develop a parachain versus when to develop the smart contract. Mainly you look at when you should develop smart contracts and when you should develop a parachain. Yeah, in case you're in Polkadot, but most of the time we develop smart contracts as a proof of concept, and we can also develop smart contracts on top of other parachains. So how it works: Ink is a programming language for smart contract blockchains built with the Substrate framework. You can choose from a number of smart contract languages which ones. So how does Ink tie into Substrate? Substrate is a framework for building blockchains. Those can be standalone blockchains or those that are connected to somehow Polkadot for security, so which are called parachains. And yeah, this I think Substrate also ships with a module for smart contracts. This module is called palette contracts. So if a parachain is developed in Substrate, it can easily add smart contract functionality by including this palette. So when you include the palette contracts, then you give a capability for builders to deploy smart contracts on your blockchain. So how does it come into play here? It's a programming language. Specifically, it's an EDSL, embedded domain specific language, for the popularized programming language. This means that you can use all normal Rust syntax plus some specifics that we added to make the language suitable for the smart contract world. Okay, so yeah, how does the palette contracts work? Intentionally design the palette contract in a way that it is decoupled from the language that is used to write smart contracts. The palette is only the execution environment and takes WebAssembly files as input. So this more of the documentation, Ink, Rust, Solidity, Ask, One include the pilot contracts on a parachain, a couple of use cases for including smart contract functionality on a parachain. We distinguish three smart contracts as first-class citizens. Yeah, chains typically take the off-the-shelf pilot contracts and create some additional innovation on top of it. Example: a star, Fala, Aleph0, T3RN. All of these use the pilot smart contract, and you can also deploy your smart contracts on these blockchains. So smart contracts are second-class citizen. Another not obvious use case, but smart contracts, second-class citizens on an existing chain. So by this we mean that the central value proposition of the chain has nothing to do with smart contracts, but it still includes them as an add-on, okay, in terms of APIs and so on. So use case 3 is as a first step into Polkadot or Kusama. So you can also build a third thing, use case for pilot contracts, is to prototype an idea as a proof of concept smart contract before leasing a dedicated parachain slot on Polkadot or Kusama. Probably when you want your blockchain to be added on the Polkadot ecosystem or Kusama ecosystem, having a pilot contract can help you to bootstrap your idea so that you can undergo through the auctioning in order to get a parachain slot. Okay, smart contracts versus parachain. Smart contracts, one of the first questions we can get somebody. Yes, this is a very valid question. When somebody learns about Substrate, Polkadot, or Kusama, is when to develop a parachain versus when to develop a smart contract. And the distinction here is that the context of Polkadot and Kusama, a parachain leases a slot for a couple of months for up to 2 years. The deal with a lease is that the parachain gets a fixed slot for executing its business logic, typically referred to as its state transition function, and can persist its modified state in a block. In Substrate terminology, this state transition function is called the chain's runtime. So mainly when you have a parachain, you lease the slot. If you want when you want to have a parachain, you auction for a slot that can be leased up to 2 years. But when you're developing smart contracts, you can develop either your own standalone blockchain while integrating the pilot contract, or you can develop on top of parachains, like develop on top of Moonbeam, on top of Asta, on top of Aleph0, and so on. Okay. So most of these, we can go through individually. The Ink versus Solidity, Ink versus Cosmosm for the Cosmos SDK thing. This is Ethereum ecosystem for the Cosmos ecosystem, and I think my place is going to be getting started. So this is my focus, where we're going to see how we can develop Ink smart contracts. Okay, so when you're going to develop Ink smart contracts, you should make sure that you have some things in place. The setup, I encourage us to develop Ink smart contracts on either Linux or macOS, because setting up this setup on Windows is somehow hard, because sometimes you have to add WSSL and things like that for Linux or Linux build up. So basically, if you have a Linux, I think it's better. It's a very good tech, or you have a macOS. But mainly to get started, in case you are looking for a guided tutorial directly toward beginners, please check out the guided tutorial. I encourage us to check out these links. They can help you to navigate. Yeah, I think we are going to look this. We shall look at this in the coming tutorials and see a guided setup of smart contracts and the like. So for setup Rust and Cargo, a prerequisite for compiling smart contract is to have a stable Rust version and a Cargo installed. So you can go through the installation guide, but I think I have Rust. So if I open my terminal, clear, hopefully it is visible now, very visible. Okay, so Rust up, is it Rust up, Rust C? Hopefully it is Rust up. Okay, so it shows that I have a Rust installed and Cargo. So the first tool, so we also have to install the Ink CLI. Now the first tool we will be installing is Cargo Contract, a CLI tool for helping setting up and managing WebAssembly smart contracts written with Ink. So you can find it on GitHub or here on Crest.io. The tool has a number of handy capabilities. So when you, after installing, you go to Cargo Contract, I think dash version, and then it will give you the version of the Cargo Contract that you've installed. If you haven't installed yet, I really ask you to go here and then view through the installation instructions. They are quite not hard, but we can look through and see. Yes, so installation, Rust app component address C, step to Cargo install Cargo Contract, and then if you want to install dylint, so there are some that are optional, but yeah, the first two steps are very crucial. Okay, you can also install it by a Docker image, but just make sure that it is installed. Alright, so we are finished installing the Cargo Contract. You have to install the installing Substrate Contracts node. Now the Substrate Contracts node is a simple Substrate blockchain which is configured to include the Substrate module for smart contract functionality. The contracts palette, yeah, it's a comfortable option. So the contracts node is like a local node that you will use to interface with your smart contract when you deploy it and so on. So it's very crucial that you also install it. It takes quite some time to download, but I think this depends on the internet that you have. But we can also go through the installation. So installing, yeah, the easiest way is to download, and after downloading, when you call this in the folder that you've downloaded, you download and you extract, and then we start it by Cargo, no. Or you don't call this, you download it and then you can start it by just calling its name in that folder. We shall see that. Or you can install it by downloading. So there are two ways. So this is the way we run it, but I think we shall see that in the coming. So one, download the binary. That's what we have been, or build it yourself by the installation mechanism. So I downloaded the binary. I can show it here. Documents. Okay, let me use this cd document, but I can just go there also. So shift control in Ink. So I downloaded the binary Substrate Contract node, Linux, and then I unzipped it to this location. So I'll come here when I want to start the node, and hopefully we're going to see it in this tutorial or in this session. So now we want to create an Ink project. things are getting yeah, excuse me. So creating an ink project, we have talked about ink being an embedded domain specific language that you can use to write WebAssembly based smart contracts. And the way we are going to create our project is with cargo contract new, then the ink smart contract name or the project name, so Flipper. So if I come and I say cd Polkadot, cd ink, okay, ls, so cargo contract new, can say flip it. So I have the reason why I'm going to use another name is I have quite a lot of flipping projects. So cargo contract, I can say flip it, so flip it and enter. So you create that, you can cd flip it, and then we start code dot so that we can see the number of files that are available. So there are some commands that are restricted from running because they take long, and also yes, a lot of files are downloaded. But so when you look at our file, we have the lib.rs. We talked of rs as library files. This is still activating. Yeah. So in this is like the main file for our smart contract. So in here we have this cfg attribute. Most of the time, actually, this is going to be the sort of the architecture, the way that the smart contract is structured. Hash in contract, then module for module, flip it, the contract name. And most of these are some things that we covered in Rust, but I'll do my best to make sure that in case something wasn't clear, or I can recover them for this. So when we are having our smart contracts, the public the pub are the functions that are visible to the user or to the person that is interacting with the smart contract. So yeah, and what I mean by this, so for example, a pub struct, this is, we start with a struct. Now this struct will store a boolean variable. A boolean variable by default is false, so that means that we shall have a value that is a false, that's assigned to false. And so the functions, these functions that are stored under the implementation, these are the functions that are going to be visible to the user. We have function pub fn, this one which will initialize the variable of the value of the value variable to false. And then we shall also have this function because they are in the implementation, they're under implementation of the flip it, and this is the implementation method. It's called a method in Rust. Yeah, so these functions are the ones that will be visible to the user. These other functions will help us to structure and also give direction to our code. So we also have this function that is default to self. I think no. I think first of all, though these ones are public, they are constructors. So a constructor is used to just initialize the value. Yeah, we have this constructor as well to initialize the value, and then we have the hash ink message. So this is where these are the functions that will be visible to the user. So we have this a mutable value. That means that so this value that was initialized, the value called false, can be mutable, can be changed to true by writing to the state of the contract or writing to the smart contract. And then this second message is to get the value. So we either get the value whether it's false or true. And yes, so the first ones were constructors. Constructors initialize our variable, and actually for every smart contract we should need to have at least one constructor. Okay, then we go to tests. So when you're writing Rust programs, you must have a test. So test, if the tests pass, that means that the code does what you want it to do, and these are like custom tests for users. Otherwise, also Rust itself does catch many errors, back to the error, but there are those tests, for example, when you want to get the sum and you want to test that this is the exact sum that you are getting, those small tests, those modular tests are done by the developer. So in here we have when we are going to start the test, we start with this cfg test, and then we put our tests inside the mod tests. So it's super. So this is our first test, ic test default works. So let's flip it assert equal flipping.get. So initially we have assigned the value to false. So we must test that false passes. Then we have another test whereby we have changed the value using the mute keyword. So let mute keyword equals flip it new assert equal dot get false, then flip it dot flip. So that means that after writing to the smart contract to change, our assertion should be true. So when you look at flip function pub fn flip, so flip function accepts a mutable variable, and what it does is that it changes the initial value to another value. So in case the initial value was false, it will now be changed to true, since it's a boolean. Alright, so I think we have gone through our code. We are not going to do a lot with our code, but then after that you can run a cargo test, so to test the code. Okay, why not better folder document cargo contract source code. Yeah, so testing your smart contract, we use cargo test. Sometimes I restrict from these because they really take some time. So say cargo test to start downloading some files. And yeah, this requires a certain time, but yes, we can go through it, and so that we are sure of the way it does. So for some of the coming sessions, for some of our coming live sessions, we shall have instances where we don't run this directly. There are some that take quite too much time, but yes, we can run. So these are the test results. We have okay works. So these are our tests. Remember, we have two testing functions. First, to get a value that was false, then second, to make sure that the false file can be turned and the test passes. So yes, that shows that it passes. Here we have, so we are good to go, and we can go to the next thing, which is to compile our smart contract. So if you want to compile your smart contract, we have a cargo contract build, and indirectly it has the dev attribute dash dash dev to ensure that you're building in a development environment. Okay, we can run this as we continue because it also takes time. Cargo contract build. So we are building a smart contract. This also takes quite some time and quite some good data. So one of the things when you read so much about developing smart contracts, one of the requirements is making sure that you have your own data. Okay, but I think we can survive here very well. Let me look at how far. 28 files out of 148. Okay, and we are still going. So this can take quite some time. I think we can continue this document so that so this command will build the following for your contract: a wasm binary, a metadata file. Metadata is usually used with JavaScript and the front end, which contains the contract's ABI and a .contract file. So which bundles both the .contract, which bundles both. This .contract file can be used to deploy your contract to a chain. If all goes well, you should see a target folder. So yeah, this is the file that we use to deploy, so the .contract file. Okay, take a look at the structure of flipper.json. How we're going to do it. So we code as flip it. 144 out of 148. That's a good speed. And error. So I don't know why this is showing. So I just had this issue. There is something here. I think I can quickly solve this by go to, it could be the version of Rust that I have. Hopefully this does not take a lot of time. So KS Rust. Where could I find Rust? Because we have substrate, we have ink count abstraction. Okay, central code. So Rust commands. So let me take this. I think this works. Okay, then let me build cargo contract build. So error is still loading the original WASM. So let me take this. And then hopefully this does not take a lot of time. But yes, this is online debugging, and many times we come through these errors. So okay, alright, the two chains table is currently in use directory override. Okay, hopefully restart component. So it's up to date. Is up to date, and then we can do this. I don't know why this is happening. Let me first restart and so error reading original WASM. This can take some time, but yes, we can wait. It's also good to walk through debugging. So as this is taking its time, we can go to some other things. So compiling, data type storage. The files describe the file describes all the interfaces that can be used to interact with your contract. Types provide the custom data types used throughout the rest of the JSON. Storage defines all the storage items managed by your contract and how to ultimately access them. Spec stores information about the callable functions like constructors and messages a user can call to interact with the contract. It also has helpful information like the events that are emitted by the contract or any doc. So if you look closely at the constructors and messages, you will also notice a selector which contains a 4-byte hash of a function name and is used throughout your contract calls to a correct function. So in the next, we will start a substrate a smart contract node and configure the contract UI to interact with it. So we have debug versus release. By default, Cargo contract builds a contract in debug mode. This means that the contract will e.g. print statements like number to the node is console if debugging was enabled on the node. So instructions here support functionality like this. The debug build over a contract includes some heavyweight logic. So for contracts that are supposed to run in production, you should always build the contract with release -- so production contract build -- release. We talked about that. This will ensure that nothing unnecessary is compiled into the WASM blob, making your contract faster and cheaper to deploy and execute. So with this behavior, Cargo contract mirrors how Cargo behaves for Rust programs. The release flag has to be passed explicitly to Cargo build. Okay, this is self-explanatory. We can meanwhile start on running the substrate node. Let me see how far we've gone. We are 300 to 700 over 800. Okay. So running a substrate node, the substrate contract is simple. So you must have this substrate contract node if you want to run your substrate contract node for you to be able to deploy your initial smart contract. Okay, this is going to take time. So after successful substrate blockchain, which is configured to include the contracts module, it is a comfortable option if you want to get a quick start. So after successful installing your contracts node, so you install the contracts node from this, and the installation instructions are here. Download the binary, or you can either download the binary or you can use this, and then usage to run, you just start a substrate contracts node. Okay, so I have to start the contract node, but I'm going to wait for this to complete, then we shall start and run quickly. Interact with your node contract UI. So the contract UI is one of the graphical user interface that is good to interact with. So when you look at the UI, we are here connected at the local node, and since we haven't started our substrate contract node, we have this. So there are other also platforms you can connect to. You can connect to Aleph 0 and deploy yours. As you test your deployment of smart contracts on the Aleph 0 network. You can you can connect to Astar Shideni, Aleph 0 testnet, Astar Shibuya, Rococo, and many more other testnets for smart contracts. Zyguest battery station. So, and then you upload your smart contract. For this example, we're going to use our local node. So let me see how far away. Yeah, almost entering 500 credits out of 700. This is a good progress. So we are going to interact with it and then deploying. So in complete, we are just going to quickly go through this and then we deploy. Now that we have generated the WASM binary from our source code and connected to a local node, we want to deploy this contract onto our substrate blockchain. So in Substrate, the contract deployment process is split into two steps: putting your contract code on the blockchain and creating an instance of your contract. With this pattern, contract code like ERC20 standard can be put on the blockchain one single time, but instantiated a number of times. No need to continually upload the same source code. Yes, so if you so for some files we shall restrain from downloading these file structures, because sometimes they can really take some long hours. So yes, we are almost entering 700 files, and yes, we deploy our first smart contract. Meanwhile, in this file, if this has issues, I have many other flipper. I have flipper 2, and we can look at the target folder. So this one compiled like successfully, and when you compile, you always get this target folder, and in the ink, this is where you have the contract. The contract wasn't, so this binary is what we are going to upload. Okay, so this is how it looks like. So this is what we shall upload. This is the .contract wasm file, and then interact with it. So I don't want to start the node without this completing. We are almost there. And the cover the domain keeps our dependencies. version is 1.76. I'm going to bring it down. 770. It's still having only 7 files. I'll have to change it when these files have completed. These files seem to be taking more than forever. Yeah, so what we are going to do is we are going to start a node from this other and we shall use the second file, so the one that I compiled. So this time we are going to use a flipper 2 since I had compiled it off when I was doing some practice. So for us to start the node is we change to cd substrate contracts node Linux. Look at this. Okay, we shall leave it there. So the other thing that we are going to do is it is called cargo contracts node. So the command is substrate contracts node. Contracts node. And as soon as we start that, so our local node has been started, and yes, so this is a success. So now we can access our UI, front-end UI. So if I refresh here, so the front end is accessible, and these were contracts that I was using for testing. So when you want to add the contract, with this we can also see that there is the node is running. So we want to add a contract, you upload, and we want to you can choose an account. I've chosen Alice test account, so name, flip it, upload a bundle. So we are going to use flipper 2, the bundle that is already working. documents, Polkadot Inc. Target Inc. and then contract. So it's the same file, nothing changed. So here you can see that we have the constructor to initialize the bool, you have the default, and then the flip. So if we click next, this we can click next again to upload. So this is the blob values of the code that we're going to generate. This is actually the contract, the dot contract, could be blob, I don't know. So this is the instance we have deployed. There has been gas. So when we look at our public methods, we have this and getting the result. So when you click on get, initial value is false. So if you want to flip the Boolean value, and we click call data again, we shall sign a transaction since we are changing the state. But for get, we are not changing anything. So get is just reading the state without. So we shall return true. And this is how we interact with our smart contract that we've deployed using a graphical user interface. So we've looked at basics, reading value, mutating the storage events, so I think yes, so this is I think this is a good place to stop, and see you in the next tutorial. See you tomorrow 7 p.m. EAT, same place. And this is still taking quite a time. Bye bye.